Question 124. For each sequence defined recursively, write the first 5 terms and then define it explicitly. So I'm going to create a quick table of values here where we will list n and then the value at that point t of n. And I'm going to include the 0th term just because I know that I need that to write the explicit equation. So 0, 1, 2, 3, 4, and 5. So I've got the first 5 terms plus the 0th term. This says that the first term is 12, and in order to move forward, the next one is 5 less than the previous term. So if I'm at 12 and I take away 5, I believe I'm at the number 7. If I'm at 7 and I take away 5, I'm at 2. 2 take away 5 would be -3, and 3 take away 5 is -8. So this is a nice linear function, right? This is not exponential. If I want to go back in time and figure out the 0th term, instead of subtracting 5, I would add 5, and that would give me 17. And then I could write the explicit definition here, and I'll use y and x. I'll say y's are equal to, let's see, -5x plus 17. So yeah, we're starting, well, the 0th term is at 17, and every single time we're subtracting 5 as we move forward. So this would be it explicitly. Let's look at B. Here's our recursive definition. It says in order to get, if you look at this, in order to get the next term in the sequence, you take the term that you're at and you multiply it by 1/2. So that's this definition. And also it tells us that the first term, right, is the number 32. So first term is 32, and then we're going to take 1/2 as we move forward. So if I make a table of values again, here's n, and then here's a of n. And I'm going to include the 0th term again. So 0, 1, 2, 3, 4, 5. So the first term I'm told is the number 32, and to move forward I always take 1/2 of that, the previous term. So the next term is 1/2 of the term I'm at. So this should be 16, and then 8, and then 4, and then finally the 5th term should be the number 2. And if I want to go backwards to pick up the 0th term, instead of taking 1/2, I would double it. So this should be 64. So that's the first 5 terms of the sequence, and I've listed them as a table. Now if I wanted to write this out explicitly, I would say, oh, the value at any term is the 0th term, which is 64, times 1/2 a certain number of times. How many times are you going to multiply by 1/2? Well, it depends on the term that you want. So if you want the first term, you're going to multiply by 1/2, right, which would give you the 32. If you want the second term, you're going to multiply by 1/2 twice. So 64 becomes 32, 32 becomes 16, right? So that gives us a 16. If I multiply by 3 factors of 1/2, I'm at 8. If I multiply by 4 factors of 1/2, I'm at 4, etc. So this is the explicit formula. This is the recursive definition. Remember, recursive definitions always need to tell you a place in the sequence, like where it starts perhaps. So they're telling me the first term is 32, and it also has to tell you how to move to the next term, and this says the next term is 1/2 of the current term.